Hello, ladies and gentlemen. This is Mr. Promo speaking to you. I am at a funeral. You guys know. That's just how it goes. I hope this will be my last sub day for the rest of the year. I know I have some sub days in January for a track meet, but literally nothing this side of 2017. So what we're going to do is take notes on 6.6, and then you are writing, because I know everybody likes to know this, you are writing this much down. I do want you to include the picture when you're writing it down. And we have 1 example, 2 example, 3 example, 4 examples. And those are going to be on your worksheet. So we'll get those passed out to you and take care of there. So I'm going to zoom in here. 6.6 is on dilations. Let me try to make this as big as I can. Maybe I'll just go right there for right now. Looks good to me. Substitute teacher, would you please press the enter button now to pause? I'm assuming you've unpaused this, and here we go. This is what you've written down. We've talked about dilations. The other thing that I want to do before I explain is I want you to have this down as well. This drawing that's in our textbook really is going to be the key to lots of stuff that we do. So make sure that you have this in your notes as well. We are going to pause to let the students write this down. So substitute teacher, please press the enter button now. Now coming back, I believe most of you have all this written down, so I want to explain what it is that you wrote, and let's talk about this stuff so you can do the problems that are on your worksheet. The worksheet we are going to hand out to you momentarily. Just be patient. First, a dilation is a transformation that is an enlargement or a reduction. It's an enlargement if your n, or your scale factor, is greater than 1. Here, our enlargement is greater. Enlargement is where we multiply by a value bigger than 1, or when we multiply by a value smaller than 1 is when it's a reduction. Those are two really easy things, two really easy concepts. Just want you to know. But the pre-image and the image stay similar. What does that mean? That means this unit is all about similarity and proportionality. So that means if we have two similar shapes, their sides are going to be proportional and their angles are going to be congruent. That's the same for a dilation. The dilation is not a rigid motion. You learned 3 rigid motions back last year in Advanced Math 8 or Honors Math 1. Or not Honors Math 1, sorry. So this is something that changes the shape. It's a different size when we dilate it. Dilations are also abbreviated as a letter D. So if you see something that looks like this, let me circle it. This D stands for a dilation with the scale factor first. That means that this is your scale factor, and the center is this. Do not assume that all the time you're going to use 0, 0 as your center. That sometimes happens, sometimes it doesn't. In this worksheet, you're going to move where the center is on several different points. So be ready for that. To find the scale factor, what you are going to do is you're going to take the ratio of any corresponding sides or the length of the image divided by the pre-image. Let me explain. In this red triangle, in this blue triangle, the red triangle is the image of the blue triangle. How do I know that? Because it has these little primes. This is the one that was done after. Something was done to this thing first, this blue one, to create this red one. This is the image. This is the pre-image. This is the before. This is the after. Well, you can tell in this picture, it's an enlargement because your scale factor is greater than 1. And so the way you can figure out what your scale factor is, this is a very big key word here. Scale factor. That's a big idea of how we're going to do a lot of math problems in this section. You take the ratio of any corresponding sides. What does that mean? That means that you can go this side over this side, and if you simplify it, you can this divided by that, and you simplify it, that ratio is the scale factor. Or I can do this other side divided by this other side, Q prime P prime divided by QP. Or you can do this other side. So you can either use let me point both fingers. The sides, you can divide them as long as they're corresponding sides and reduce that in lowest terms, and that's how you find the scale factor. Or there's a second way to do it as well. And you may not gather this, but it is the length of the image divided by the pre-image, meaning this distance here from the center, I don't know if you know this, but this is the center, to the farthest point. It doesn't even matter which one we use. We can use C R prime. We could even use C Q prime. We could even use C P prime. And we just divide it by the distance to the pre-image. The distance to the image divided by the distance to the pre-image. That ratio is going to be exactly the same ratio as these other sides because they're proportional. That's the really neat thing about these dilations. This dilation is, like I told you, an enlargement. You could do the same thing as a reduction if you wanted to, and you would just change these two values. The primes would be over here instead of over there. And so I'm hoping that kind of makes sense to you. Okay, so what I want to do next is I want the substitute teacher, now I want you to pass out the worksheet that is assigned for all students, the 6.6 worksheet. But please press the enter button now, and when you're done passing out the worksheets and everybody has one, then go ahead and press enter again. So now you all have a worksheet. As I like to do in this class, I like to do examples with you. And so here is example number 5. It's on your worksheet. You have it in front of you. You do not need to write it in your notes. You can do this on the worksheet if you would like. You know how I like to do these things together. So number 5 says, the solid line figure is a dilation of the dashed line figure. So solid line, that is a dilation. What does that mean? That means that this one is the image of the dashed line figure, which must mean that that is the pre-image. You have to pay attention in all these problems to figure out which one does it start with and which one does it end with, because I've done some worksheets where the solid line is the pre-image and some worksheets where the solid line is the image. So make sure you're paying attention to the directions. They'll let you know. If it doesn't let you know, ask and I will let you know. The labeled point is the center of dilation. This is the center. P is the center, just in case. Tell whether the dilation is an enlargement or a reduction. Okay. So we're going from the dashed line figure to the solid line figure. Dashed line, solid line. Is it an enlargement or is it a reduction? I could tell that most of you have that right already. It is an enlargement. That's the easy part of the question. But then it says, then find the scale factor of the dilation. So how do we find the scale factor like this? It goes with what we talked about before. If I want to know what the scale factor is, we can either take side divided by side, or we can take distance from the center divided by of the image divided by the distance from the center to the pre-image. Here's what I would do. I'm going to go like this and just say, I know what the image distance is on the right side. What is this distance? 1 unit, 2 unit, 3 units, 4 units, 5 units, 6 units. Now for the pre-image, do I know what the right side this value is? 3. If I take the image divided by the pre-image, that's what this basically says. The image divided by pre-image. I'm just going to write that down here. Image divided by pre-image. The image distance was 6 units. The pre-image distance was 3 units. If I think about what that is, that's 2 over 1, which reduces to 2. My scale factor is 2. Now let's just say that I go, hey, is that right? I could double check. I can check and see if this 4 is double this. Is it? Or we can check here, 4, and check here. Is that double that? Is this is 2? Is that double the 1? Is this diagonal, which is root 2? Is that 2 root 2? Which it is, and so on. So you can check all the sides. I didn't check this other side, but it is 4, and there's another 4 there, which makes that whole thing 8. You see it? Perfect. By the way, do I want your scale factor as 2 over 1? What's more simplified? I would go with the 2. It's easier to write that way. The only time you need to have the 1 is if it's in the numerator and it's 1 to 2, 1/2 would have to be written that way. Second example is number 9. I was totally confused when I looked at your worksheet. I needed to kind of like have a bit of a picture. Okay? You're looking underneath the magnifying glass. That's my best magnifying glass right there, okay? And then you see a ribbon. There's a ribbon down here. But up here you see something like that. And the image is 10 times the ribbon's actual size and has a width of 1 centimeter. So this thing is making everything 10 times bigger. And we need to figure out its actual size. Find the actual dimension of each object. Like how long is this this ribbon? So I kind of do it like this. I have a picture there just to kind of demonstrate what we're doing. 10 times the ribbon's actual size. I'm just going to take that and I'm going to go like this and write 10 times the ribbon's actual size. 10 times actual size. Has a width of 1 centimeter. Has a width of 1 centimeter. So equals 1 centimeter. So what we have is we have 10 times actual size equals 1 centimeter, just based off of this sentence. If we want to find this actual size, then what I do is I divide by 10 and I divide by 10 and I get actual size is 1 centimeter divided by 10 is 0.1 centimeters. That means that in this picture, this is 1 centimeter in the magnifying glass. And we're trying to find out, well, how big is it over here? It's 1/10 of a centimeter because it was made 10 times bigger. Most of you already know that. I get it. But I wanted you to see how when you go from a sentence, for those of you who struggle with word problems, you know who you are. This is a good way for you to write the equation. Going on. Number 14. A dilation has a center of 0, 0. Find the image of each point for the given scale factor. This is our point. This is one point on an object. We don't know what the object is. It doesn't matter. It's like we're going back up here and we're saying one point is, and they're giving you coordinates for one of these points, and we're going to find what the image would be. This is very easy to do. If I know that the point P is at -3, 5, and this is the scale factor, they do something a little differently. They don't put the center here. This is not in parentheses. The P is in parentheses. So what that means is that we're doing a dilation of point P. That's what that means. And we're doing a dilation with a scale factor of 1.2. I'm hoping, it didn't ask this question, but I'm hoping you know it's an enlargement. How come? Because this is 1.2 times bigger. If this is greater than 1, it will make an enlarged figure. So if I have point P, it's -3, 5, and I'm doing this 1.2 times bigger, guess what happens to -3, 5? We multiply both things by 1.2. You can do this on a calculator, but P prime would be at a new place. -3.6, comma. Six. I'm going so slow because I'm double checking my mouth. I'm like, it's too easy, and my brain is starting to hurt at this point. This is where that point would be after a scale factor of 1.2. And we're using the center of 0, 0. That's what's happening. It's all we have to do. You will do this on all the problems that are right next to it, number 14. Last one. Number 23. Number 23, you're going to do a dilation of, with a scale factor, let me write that below here, scale factor. And then this is the center of what? Of triangle BCD. So we're going to have a center point. Here's my center point. And we're going to have a scale factor of 0.8. What you are going to do is you are going to measure each side. You are going to measure, you're going to get a ruler, and you're going to figure out how long each side is, and this really doesn't matter. See, I'm kind of like cheating at this point. So my measurement is not going to match yours. You will have to measure yourself. Okay? Rulers are available in the room, or you might have your own. Just for simplicity's sake, I'm going to pretend that this side here is 5 centimeters. Because right now, that's what that says. The length of BC is 5 centimeters. Which means that if I go 0.8 times the whatever you get, I got 5 centimeters. And it is 44.0 centimeters. Well, a scale factor of 0.8, that means B prime with the center of C means that B prime will be right here, B prime. That's how it works. This distance is 5 centimeters. This distance is 4 centimeters. It has a scale factor of 0.8. Does that make sense to you? You're going to do the same thing. Whoa! You're going to do the same thing for D prime. Oh my goodness. It's a little bit past 11. I have to get a bigger ruler to do this. Do I have a bigger ruler? Oh, look at that, I do, in my drawer. There we go. This one's dirty. Oh man, I'm just doing everything. My measurement's going to be different than yours. I'm going to say that this is 11.5 centimeters, and I'm going to multiply that by 0.8 to figure out how far I got to go. I'm going to use my calculator just because I don't feel like doing that. And I get that it's 9.2 centimeters. Where is 9.2 centimeters from C? Because C is our starting point. That means my new D prime is right here. How far do you go for C to get to C prime? Guess what? Because it's the same center point, it doesn't go anywhere. And then what you can do is you can actually connect the dots, which is kind of fun. And I hope you see that these two objects are similar. The dilation, that the red triangle that I just drew is smaller, it's a reduction. All the angles are the same. These two lines are parallel. We have a side splitter thing. We have proportionality. It's wonderful. That's kind of how it all connects. Okay, perfect. We're going to end the notes right there.